All right, in this video, we're going to talk about polynomial functions. And we're going to, in this video, talk about local behavior. And so this is going to tell us why the polynomial functions are wiggly in the middle. All right, so before we start talking about the local behavior, let's just once again discuss just general polynomial functions. All right, so we have two different shapes that polynomial functions come in. They either look like parabolas that are wiggly in the middle, or they look like snakes that can be wiggly in the middle. And we know that if my leading coefficient is an even number, then they'll look like the parabola. And if it's an odd number, then it's going to look like the snake. Now, also, the leading coefficient, the number in front of the leading term, which is the highest exponent term. So if our highest exponent is even, it looks like a parabola. If our highest exponent is odd, then it looks like a snake. If the number in front of that leading coefficient, of that highest degree term, is positive, then it will look like a W. If it's negative, then it'll look like it'll open downward, right? Same thing here with the odd exponent. If it is positive, then it'll look like an increasing snake. And if it's negative, then it'll look like a decreasing snake. All right? So either a parabola or a snake. If it's an even exponent is your highest power, it looks like this, the parabola. If it's odd, then it'll look like the snake. If the number out in front is negative, then we know it looks like this or this. If the number out in front is positive, then it looks like this and this, if the number of the leading coefficient is positive or negative. Also notice a couple of things. These are always smooth curves, all right? So they don't have any jagged edges. It's always smooth. And it's always continuous. All right, so in other words, continuous means you can draw it without picking up your pencil. So if you remember the volcanoes and the boomerangs, those were not smooth those were not continuous curves. They were smooth but not continuous, because with the boomerang, we had to pick up our pencil to draw the other side. Same thing with the volcano. You have to actually pick up your pencil. So not continuous. They have that vertical asymptote on them. So you had to pick up your pencil to get to the other side of the asymptote. So we don't have anything like that. We won't have any asymptotes on polynomial functions. Also, with the absolute value, remember that was a V shape. It had that sharp curve at the vertex. It was a V, so it made that point. Well, these are not going to have points. They're always going to be smooth. They're not going to have any kind of jagged edges, okay? And so that's what it means to be smooth and continuous. And polynomial functions are always going to be smooth and continuous functions. All right, also notice that we talked about the end behavior. So with the end behavior, when I'm going to the left, so let's look at just this function. When I'm going to the left, this one's going up, it's going positive. And so as I go to the left, or towards negative infinity, this one goes towards infinity. As I go to the right, or towards positive infinity, this one goes to infinity. This one, as I go to the left, it goes down, so it goes to negative infinity. And as I go to the right, it goes down, so it goes towards negative infinity. Looking at this function, as I go to the left, as x goes towards negative infinity, this one goes down. It goes negative, so it goes to negative infinity. But as I go to the right, this one goes up to positive, so positive infinity. On this function, as I go to the left, towards negative infinity, as x goes towards negative infinity, what is y doing? It's going up, positive, so positive infinity. And as I go to the right, or towards positive infinity, then my y value is going down, and so it's going towards negative infinity. So that was the end behavior that we talked about in the last video. So now I'm going to look at this function. So the first thing that I want to do is I want to figure out what is it going to look like. That's the first step. Is it going to be a W, or is it going to be a snake? Is it going to be a parabola or a snake? Well, what's my highest exponent? It's x cubed. And so since I have x cubed here, I know that it's going to be a snake. Now, will it be an increasing snake or a decreasing snake? So I look at my number that's in front of that x cubed term, and it is -2. So my leading coefficient is -2, so it's going to be a decreasing snake because it's negative. So I'm just going to draw this here just to remind myself that this is going to be a decreasing snake. Now, finally we get to local behavior. All right, so with the local behavior, I am going to find my x and y intercepts. So first of all, let's look at our y-intercept, and that's where x is equal to 0. Now these are also called vertical intercepts because the y-axis is the vertical axis. Okay? So y-intercept or vertical intercept, you're going to let x equal 0. So if I let x equal 0, 0 cubed would be 0 times -2, still 0. 0 squared is 0, so times 6, still 0. And then 4 times 0 is 0. So 0 plus 0 plus 0. So my y-intercept is going to be 0. And notice here that there is no constant term. There's no number by itself. And so anytime you have that, your y-intercept is going to be 0. Now let's look at our x-intercepts. And again, these are sometimes called horizontal intercepts. And they're also called zeros. All right, so x-intercepts have 3 different names: x-intercepts, zeros, and horizontal intercepts. But they are where the y is equal to 0. So if I let y equal 0, I get 0 is equal to -2x cubed plus 6x squared minus 4x. All right? So now I know that I can take out, they have a common factor. They're all divisible by 2, and they're all divisible by x. So I'll take out the 2 and the x, and while I'm at it, I would like for my leading coefficient to be positive because it makes it easier to factor. So while we're doing this, we're going to take out the negative as well. So I'm going to take out a -2x because everything is divisible by 2 and everything has an x in it. And then to make the leading coefficient positive, I'm going to take out the negative. So anytime this leading coefficient is negative, go ahead and factor out that negative. So taking out the -2, -2 into -2x cubed, the -2's cancel, and I get x squared. X and x cubed, this x cancels with one of those x's to leave me with 2. Then negative into positive is negative. 2 into 6 is 3. X and x squared, x. And then negative into negative is positive. I'm sorry, yeah. And then 2 into 4 goes 2, and then the x's cancel. All right? So now I'm going to factor. I need to keep factoring because I still have an x squared term. So we're going to focus on this 2 because remember x squared is always going to be x times x. And then the 2 factors into 1 times 2. and that does give me 3, but I want it to be -3, so the right number but the wrong sign. So I change both of the signs. So when I multiply them, -1 times -2 does still give me +2, but when I add them, -1 minus 2 gives me -3, which is what I'm looking for. So -1 and -2. So this gives me, now I've got 3 things multiplied together to give me 0. So that means that one of them is 0. So either 2x is equal to 0, or x minus 1 is equal to 0, or x minus 2 is equal to 0. Here, divide both sides by -2. I get x equals 0. Here, add the 1. Here, add the 2. So I have 3 x-intercepts. Now that should not be surprising to you, because remember, if you have x cubed, that means that you'll have at most 3 x-intercepts. Right? So now let's draw it. So notice here that both my I have a x-intercept and a y-intercept of 0. And that should not be surprising, because if the y-intercept is 0, it means it hits at the origin, so you'll also have an x-intercept at 0. And then I'll have an x-intercept at 1 and an x-intercept at 2. Now, let's look back at what I originally looked at, and that is the fact that it's a downward snake. So this is where the wiggly in the middle comes in. I know that it starts up high and it ends down low. So it should start up here and it should end down here. So I'm going to start up here, and then I'm going to have to keep coming down, and then it turns around, and again, a smooth curve, don't make it a V, make it a U looking thing. Then it's got to come back up and hit this point, and then it's got to come back, and again, it comes up, and I don't know how far up, you don't learn that until another class. And then it's going to come down and hit this point, and then keep going. All right, so it does look like a snake, and notice how it gets to be wiggly in the middle. It's because it has these extra x-intercepts. And notice that I have 3 x-intercepts, so it turns around. It has 2 turning points, because in between these 2 it has to turn around, and in between these 2 it turns around. So you have at most, because of the x cubed, you have at most 3 x-intercepts, and you have 2 turning points. All right? Also, I want you to remember that this x-axis is like a fence. And on the fence, you can't go under it, you can't go over it. You have to go through the gate. So these x-intercepts are like the gate. You cannot make your graph hit at any other point on the x-axis except for at these gates. All right? And so it can't have extra points, like I couldn't make this go back up and then come back down, because there are no gates over here. There are no x-intercepts. So it can only hit the x-axis at these x-intercepts. You can't make new ones. All right, problem number 2 says f of x is equal to x to the 4th minus 4x squared minus 5. All right, so first of all, my y-intercept, first of all, what is the shape of the graph? Well, let's look at our highest power of x to the 4th. So the x to the 4th looks like a parabola because it's an even number, and it's positive, so it will be opening upward. So this one's going to look probably like a W. Okay, so my y-intercepts, or vertical intercepts, I let x equal 0. And so that would give me This is 0, this is 0, negative 5. Y is equal to negative 5. All right, so on this one, notice that this constant term gives you your y-intercept. Your constant term always gives you your y-intercept, because this would be 0 and this would be 0. So the only thing that you have left is this constant term. So the term that has no x's is called the constant term, and it is the one that tells you what your y-intercept is. Then we're going to look for our x-intercepts, also known as horizontal intercepts or zeros. All right, so looking at our y-intercepts, I'm going to have our x-intercepts, I'm going to have y equals 0. And so, of course, in order to do this, I have to factor it. So this is going to be, now remember, we could do this by u substituting, but this is so easy, you really don't need u substitution. Whatever this middle term here is what will be your first two terms in your parentheses. So the x to the fourth is x squared times x squared. So that's how you get the x to the fourth. So you key off of this middle term. Whatever the middle term is what you're going to put as the first thing in your parentheses. All right, then I'm looking at negative 5. So negative 1 times 5. And that's the only two terms that I could have for, only two factors of 5 are 1 and 5. And one of them has to be negative. So negative 1 plus 5, 5 minus 1 is going to be 4, but I want negative 4. And so that means right numbers but wrong signs, so plus and minus. Okay? So this will be plus 1 and minus 5. So two terms multiplied together. I can't factor either one of them, so I'm going to have to solve it by the square root method. So I'm going to either have this term equal to 0 or this term equal to 0. So here, subtract the 1 from both sides. And so if I take the square root of both of them, plus or minus, I would get plus or minus I. Now, on our graphs, there are no imaginary numbers. There's only real numbers. So these two don't count. They are factors of the, or zeros of the polynomial, but they don't count on our graph. And then here I'll have 5 is equal, if I add the 5 to both sides, and then take the square root of both sides, I get, don't forget plus or minus the square root of 5 equals x. Now, I have to put this on the graph, so if you want to kind of get an idea of where that is, all you have to do is go 5 and take the square root of it. So it's about 2.2. So if you're putting it on a graph that has grids on it, it would be at around 2.2 is where you would draw it. So on this one, I only have two x-intercepts, negative square root of 5 and positive square root of 5. All right. Now, I said that this one was going to look like a W, but notice it only has two x-intercepts. Now, I also know that my y-intercept is at negative 5. So 1, 2.2, 1, 2.2. All right, so this one, it could still be wiggly in the middle, but we don't know that. We just know that the end behavior looks like this, and we know it hits this point, and then we know that it hits this point, and we know that it goes up because it starts up and it ends up. And so, again, this one could kind of do weird things down here, but we don't know that, and we don't know how to determine that. And so we're going to just look at it and say, okay, this is what its basic behavior is going to be like. All right. So on these graphs, we found the x-intercept, the y-intercept. We looked at the shape of our graph, and then were able to plot both of them.